Chapter 13, Basic Op-Amp Circuit. I'm going to go through a couple of revision questions. The signal that you would expect at the output of a comparator, there at the arrow, is a series of alternating positive and negative triggers, sine wave, square wave, or DC level. It is a square wave due to this RC network here on the output part. Hysteresis is incorporated in a comparator by adding a capacitor in series with the input, a capacitor from a power supply to ground, a small resistor in series with the input, positive feedback. There you can see feedback go via R1, R2 to the positive side of my op-amp. So therefore, it is a comparator with positive feedback for hysteresis. So that answer is D. To find the trigger point for a Smith trigger, you can divide the saturation voltage by 2, apply Kirchhoff voltage law, apply the voltage divider rule, calculate the rate of change of the input. Your V upper trigger point is R2 divided by R1 plus R2 multiplied by V out max. So you can see that is basically the voltage divider rule that is being applied there. A comparator output can be limited or bounded by the reversing the power supply voltages, putting a Zener diode in feedback path, decreasing the input resistance, connecting the inverting input to ground. There you see, we basically, a comparator of output banding, there's a Zener diode in the feedback path. Assume all resistors in the circuit shown here have the same value. The circuit is a summing amplifier, averaging amplifier, scaling adder, none of above. When RF is larger than the input resistor, the amplifier has a gain of RF over R1, where R is the value of each equal value input resistor. The general expression for the output is a summing amplifier. Assume all resistors in the circuit shown here have different values. Circuit summing, average amplifier, scaling adder, none of the above. A different weight can be assigned to each input of a summing amplifier by simply adjusting the values of the input resistor. So that is the scaling adder. The circuit shown is A to D converter, R to R ladder, both of above, none of above, and R to R ladder, digital to analog converter. A practical integrator has a feedback resistor in parallel with a capacitor. The purpose of a resistor is to avoid noise, increase the gain, both above, none of above. It is none of above. A certain circuit has an input and output signal shown. The circuit is a differentiator, an integrator, a scaling amplifier, none of above. You can see it's a triangular wave to rectangular wave, so therefore that is a differentiator. A differentiator circuit produces an output that is proportional to the negative of the sum of the inputs, rate of change of inputs, area under the curve of the inputs, none of above, and that is a rate of change of the inputs. An op-amp comparator has an output dependent upon the polarities of the two inputs. Is it true or false? It is true. Why? Because a comparator is a specialized op-amp circuit that compares two input voltages and produces an output that is always at either one of the two states, indicating that the greater or less the relationship between the two inputs. The output voltage of a summing amplifier is proportional to the product of the input voltages. True or false? That is false, because a summing amplifier has two or more inputs, and its output voltage is proportional to the negative of the algebraic sum of the input voltages. Integration is a mathematical process for determining the area under a curve. True or false? That's true. Why? Because an op-amp integrator stimulates mathematical integration, which is basically a summing process that determines the total area under the curve of a function. A square wave input to op-amp integrator will produce a sine wave output. True or false? That is false, because the output voltage V out is the same as the voltage on the negative side of a capacitor. When a constant positive input voltage in the form of step-up pulse, a pulse has a constant amplitude with height, is applied, the output ramp decreases negatively until the op-amp saturates at its maximum negative level. Bounding allows for op-amp to have unlimited output voltage up to the value of a supply voltage, true or false. That is false, because in some applications, if necessary, to limit the output voltage level of a comparator to a value less than that provided by the saturated op-amp, this process of limiting the output range is called bounding. An op-amp has an open loop gain of 100,000, VSAT, plus 12, minus 12. A differential signal voltage of 150 microvolts peak to peak is applied between the inputs. The output voltage is equal to, using the formula, V out is I open loop multiplied by V in. So V out is 100,000 multiplied by 150 microvolts peak to peak. So V out is equal to 15 volts. Since 12 volts is the peak to peak limit, the op-amp saturate, and V out is, in other words, 2 times 12, that gives you 24 volts peak to peak. A summing amplifier can add DC voltages, AC voltages, DC to AC voltages, all of the above. Op-amp amplifies both DC and AC signals, so therefore that is all of above. Determine the output level. Is it maximum positive or maximum negative for the amplifier indicated here? In this particular case, you can see negative 1 volt is applied to the inverting input, so the output is definitely going to be maximum positive. In the second case, my input is applied to the positive or the non-inverting input, and that's a positive signal, so my output is also going to be maximum positive. In this case here, there's a 3 volts, there's a 4 volts, so the highest voltage is basically being applied to the inverting input, so my output is going to be maximum negative, because it's a positive signal that's been applied there. Output is going to be negative 180 degrees out of phase, so it's going to be a negative signal. Each of the following is used to establish a reference voltage in a comparator, except for a voltage divider, Zener diode, LED, a battery, the LED. Refer to figure A. In the figure, if a solder splash is shorted, the two ends of a feedback resistor to each other, the output voltage would be 0,5 minus 0,5, 0, minus V sat. We know that V out is minus RF over R times V in 1 plus V in 2. So V out is 0 over 5,000, negative 1 plus 1.5. V out is equal to 0 volt. Refer to B in the figure above. A voltmeter placed from the inverting input to ground would read minus 0,925, minus 2.775, 2.775, equivalent equal to 0. You say you're going to read there a virtual ground, so it's going to be equivalent to 0. Refer to the figure A above. This circuit is known as a multivibrator. Zero level detector, comparator with hysteresis, non-inverting amplifier. In order to make the comparator less sensitive to noise, a technique incorporated positive feedback called hysteresis can be used. Basically, hysteresis means that there is a higher reference level when the input voltage goes from a lower to a higher value than when it goes from a higher to a lower value. So in this case, that is a comparator with hysteresis. Calculate the upper trigger point and the lower trigger point. The upper trigger point is R2 divided by R1 plus R2 multiplied by V out, and that gives you an answer of 1.410. And the lower trigger point is negative 1.410 volts. And the answer Referred to B in the figure above, this type of circuit will usually have a square wave output if the input is a sine wave, a triangular wave output, a ramp output for a square wave input, none of above. If you look there, we will find that when the output is at maximum positive voltage, the input exceeds the upper trigger point output and switches to maximum negative voltage. When the output is at maximum negative voltage, the input exceeded a lower trigger point output switches to maximum positive voltage. So in other words, your answer is a square wave output if the input is a sine wave. Refer to B in the figure above. The output voltage with the input as shown is positive VSAT, negative VSAT, 10.5 volts peak to peak, 17.06 volts peak to peak. A closed loop of a non-inverting amplifier is 1 plus RF divided by RI. If you calculate that or substitute the values, you find a value of 5.255. So V out is a closed loop of a non-inverting amplifier multiplied by V in. It's 5.255 times 2. That gives you 10.5 volts peak to peak. So therefore my answer is C. See figure A. The circuit is known as a non-inverting amplifier, an integrator, a differentiator, a summing amplifier. An op-amp differentiator simulates mathematical differentiation, which is a process of determining the instantaneous rate of change of a function. The differentiator is shown in this figure A. Notice how the placement of a capacitor and resistor differ from the integrator. The capacitor is now the input element and the resistor is the feedback element. A differentiator produces an output that is proportional to the rate of change of an input signal. So the answer is C, a differentiator. Refer to the figure above. Which of the circuit is known as an integrator? An op-amp integrator simulates mathematical integration, which is basically a summing process that determines the total area under the curve of function. The integrator is shown in figure B. Notice that the feedback element is a capacitor that forms an RC element with the input resistor. So in this particular case, B is your integrator. Refer to figure B in the figure above. A square wave input is applied to the circuit. The output voltage is most likely to be a square wave, triangular wave, sine wave, no output. The constant current IC charges the capacitor linearly and produces a linear voltage across the capacitor. The positive side of a capacitor is held at 0 by virtual ground of an op-amp, and the voltage at the negative side of a capacitor, which is the op-amp output voltage, decreases linearly from 0 as the capacitor charges, as shown in the figure below. When a constant positive input voltage in the form of a step or pulse, a pulse has a constant amplitude with height, is applied, the output ramp decreases negatively until the op-amp saturates at its maximum negative level, as indicated in this figure above. So the answer is going to be a triangular wave. A Smith trigger is a comparator with hysteresis, 1 trigger point, 2 trigger points, A or C. Smith triggers is comparators, not exclusively circuit that makes use of positive feedback. Small changes in the input lead to large changes in the output of the same phase. To implement hysteresis, a fancy word for delayed action, and is used to remove noise from the analog signal while converting it to a digital one. So the answer here is A and C above. An op-amp has an open loop gain of 90,000, VSAT plus minus 13 volts, a differential voltage of 0.1 volts peak to peak is applied between the two inputs. The output voltage is equal to, gain is very high, VSAT is plus and minus 13 volts, plus 13 volts or minus 13 volts. So V out is 13 minus 13 volts, that gives you 26 volts. So my answer is D, 26 volts peak to peak. The output of a Smith trigger is a triangular wave, sine wave, sawtooth wave, square wave. In this particular case, it is clear that it is a square wave. The integrator circuit uses capacitor at its feedback circuit, produces a ramp voltage at its output for step input voltage, uses an inductor in a feedback circuit, A and B above. The feedback element for integrator is a capacitor that forms an RC circuit with an input resistor. So the answer is A and B above. A differentiator circuit uses a resistor in its feedback circuit, uses the capacitor in its feedback circuit, produces a square wave at its output for a triangle wave input, A and C above. The placement of a capacitor and resistor differ from an integrator. The capacitor is now the input element, the resistor is a feedback element. A differentiator produces an output that is proportional to the rate of change of the input voltage. So that's both A and C. Hysteresis voltage is defined as a voltage of a lower trigger point, a voltage of an upper trigger point, the difference in voltage between the upper and lower trigger points, the sum of voltages of the upper and lower trigger points. In order to make a comparator less sensitive to noise, a technique incorporated positive feedback called hysteresis can be used. Basically, hysteresis means that there is a higher reference level when the input voltage goes from a lower to a higher value than when it goes from a higher to a lower value. A good example of hysteresis is the common household thermostat that turns the furnace on at the temperature and off at the other temperature. So the answer is the difference in voltage between the upper and the lower trigger points, number C. A comparator is an example of an active filter, current source, linear circuit, and non-linear circuit. We know that a comparator is a specialized op-amp circuit that compares two input voltages and produce an output that is always at either one of the two states, indicating the greater or less that relationship between the inputs. Comparator provide fast switching times, and many have additional capabilities such as fast propagation delay of internal reference voltages to optimize the comparison function. So that is a non-linear circuit. If the input of a comparator is a sine wave, the output is a ramp voltage, a sine wave, a rectangular wave, or a sawtooth wave. One application of op-amp used as a comparator is to determine when an input voltage exceeds a certain level. If you look to figure 13.1a, you will see a zero level detector. Notice that the inverting input is grounded to produce a zero level, and that the input signal voltage is applied to the non-inverting input because the high output voltage gain is very small difference voltage between the input drives the amplifier into saturation, causing the output voltage to go to its limits. Figure 30.1b shows the results of a sinusoidal input voltage applied to the non-inverting input of a zero level detector. When the sine wave is positive, the output is at maximum positive level. When the sine wave crosses zero, the amplifier is driven into opposite state and the output goes to its maximum negative level as shown. As you can see, the zero level detector can be used as a squaring circuit to produce a square wave from a sine wave. So in this particular case, that's that rectangular or your square wave signal. Zero crossing detector is a comparator with no output, comparator with a trip point reference to zero, a peak detector, or a limiter. When the sine wave is positive, the output is at its maximum positive level. When the sine wave crosses zero, the amplifier is driven to its opposite state and the output goes to its maximum negative level as shown. As you can see, the zero level detector can be used as a squaring circuit to produce a square wave from a sine wave. So that is a comparator with a trip point reference to zero. A window comparator has only one usable threshold, uses hysteresis to speed up a response, clamp the input positively, detects an input voltage between the two limits. A window detector circuit also called a window comparator circuit or dual edge limit detector circuit, is used to determine whether an unknown input is between two precise reference threshold voltages. It employs two comparators to detect over voltage or under voltage. So the answer is detect the input voltage between two limits. A Smith trigger has only one trip point, only negative feedback, two slightly different trip points, a triangular output. It is two slightly different trip points. A Smith trigger is a comparator with negative feedback, positive feedback, neither A or B, both A or B. It is positive feedback. The circuit overcomes the problem of false switching caused by noise on the limits, on the inputs, is an input buffer, Smith trigger, input noise eliminator, a differentiator. It is a Smith trigger. The amount of hysteresis in a Smith trigger is defined by a difference in upper trigger point minus the lower trigger point, a product of upper trigger point and the times the lower trigger point, division of upper trigger point divided by your lower trigger point, the sum of upper trigger point plus your lower trigger point. In this particular case, that is the difference of the upper trigger point minus your lower trigger point. Output bounding is the process of the output voltage range of a comparator, extending, limiting, comparing, filtering. It is limiting. So in other words, output bounding is the process of limiting the output voltage range of a comparator. If all the resistors in the summing amplifier are equal, the output will be equal to the average of individual inputs, inverted average of the individual inputs, sum of the individual inputs, inverting sum of the individual inputs. V out is RF over RI, multiplied by V in plus V in 2 plus V in 3. So if RI is equal to RF is equal to R1 is equal to R2, R3, then RF over R1 is equal to V out is equal to 1 multiplied by V in 1 plus V in 2 plus V in 3. So that's the inverting sum of the individual inputs. But what of the input makes a summing amplifier circuit possible? Virtual ground at the non-inverting input, virtual ground, low voltage, and a high voltage. So in this particular case, we can see that is the virtual ground. A D2A converter is an application of an adjustable bandwidth circuit, non-inverting amplifier, voltage to current converting, scaling adder. One method of D2A conversion uses a scaling adder with input resistance values that represent the binary weights of a digital input code. So that is a non-inverting amplifier. An op-amp integrator is the current through the input resistor is into the inverting input, non-inverting input, bypass capacitor, and a feedback capacitor. It is a feedback capacitor. A mathematical operation that determines the rate of change of curve is called differentiation, integration, curve averaging, linear regression. It is differentiation. A mathematical operation for finding the area under a curve of a graph is called differentiation, integration, curve averaging, linear regression. It is integration. The formula IC is equal to VC divided by T multiplied by C shows that for a given capacitor, if a voltage changes at a constant rate with respect to time, then the current will increase, decrease, be constant, decrease logarithmically. We know that since the current at the inverting input is negligible, IR and IC, both currents are constant because the slope of a capacitor voltage VC divided by T is constant. The output voltage is also constant and equal to the voltage across RF because one side of a feedback resistor is always zero, virtual ground. So it's gonna be a constant. A bounded comparator uses a feedback circuit, equal value resistor, Zener diode, and inductor, a resonant filter. Here you can see there's a Zener diode being used. So in some applications, it's necessary to limit the output voltage level of a comparative value less than that provided with saturated op-amp. A single Zener diode can be used, as shown in figure 30.10, to limit the output voltage to the Zener voltage in one direction and to forward the diode voltage drop in the other. The process of limiting the output range is called bounding. So the answer for this particular one is going to be a Zener diode. A two-input summing amplifier has input voltages of 3 volts and 4 volts. If RF is open, the output voltage will be approximately minus V sat. An R2R ladder circuit would be found in a common emitter amplifier, differential amplifier, a Smith trigger circuit, a D to A converter circuit, a D to A converter circuit.